Hey, it's Mrs. Golding. I just had a request for a few more Friday paper questions this week. I know we've done many of these in class, but perhaps you need them as well. So if it's helpful, then so be it. Let's see if I can get this a little fatter. All right. Now, question number 6 says, if I can get it to come down, find the slope of the line that passes through these 2 points. So we're going to use our slope formula. And remember, that means we're going to find the m. And we put our vinculum minus minus because we're finding the change in y over the change in x, the vertical change, yes, over horizontal change. So I said, let's take the points and we're going to rotate them counterclockwise. So when I do that, when I rotate this counterclockwise, the 4 goes on top, -3 goes on the bottom. Rotate that counterclockwise, right? -2 and 1. Then let's go ahead and subtract. 4 minus a -2. What is that? That's 4 plus 2, which is 6. And then -3 minus 1. So I'm -3, and then I'm going to go to the left on the number line 1. So I'm at -4. I can divide both of these by 2. And so half of 6 is 3, and half of -4 is -2. We always want to try to put our slope into simplest form. Now, that doesn't mean I need to make it a mixed number. Slope is best left improper. Okay? So let's go ahead. The next one that was asked for was number 11. So number 11, I know, is frustrating to a lot of people because there's no one answer. And that's what's frustrating. So we're looking for an equation. So I know it has to have an equal sign. And it has one solution. Now, if I put the same thing on the equal sign, on each same expression, like 2x plus 1 equals 2x plus 1, I have a variable on both sides, right? But I'm not going to get one solution. When the expressions are exactly the same, then I'm going to have infinite solutions, right? So I can't do that. So first thing I'm going to do is choose a variable. I'm just going to choose x, right? That's probably one of the favorites. And I like the number 11, so I'm going to choose that. This is literally what you're going to do. You do not choose my problem, okay? If you write this problem on your paper, I'm not going to count it right. Okay, because I want this to be up to you. So I've got, on my side, I'm going to use an x and an x. So I have to put an x on both sides of the equal sign. Because it says in here, a variable on both sides. Now, I know that for x, I'm going to substitute an 11. So I'm just going to go ahead and do that. And then I'm going to take the variable, or I'm going to take the 11 on the left side just because I want to. That's the side I'm going to deal with, and I want to manipulate it somehow. So I'm going to use my operations to do that. So I'm going to do, I don't know, let's multiply it by 3 and add 7. Oh, are they all prime numbers? Ooh, I wonder if I'll get a prime number. Those are the kinds of things mathematicians ask themselves. They do stuff and they're like, I wonder. So let's just check it out. 33 plus 7. 33, 34, 35, 36, 37, 38, 39, 40. Oh, I did not get a prime. I did not even get an odd. Got an even. Weird. I wonder if that happens every time. That's the kind of thing that people are like, maybe I should test that, right? Okay, so then 40 over here. Whatever, when it's truly an equation, whatever expression you have on one side must be equal to the expression on the other. Not exactly the same necessarily, not the same expression, but the same value of the expression when I evaluate it. So I have to do something different to this 11 to get a 40. 11 times 2 is 22. 22. What's 40 minus 22? Let's see. 3, 18. So that means plus 18. 22 plus 18 equals 40. Is that true? Yes. So now I have written two expressions that are equivalent on each side of the equal sign. That's what I'm doing when I build an equation. I'm going to now take the number 11 out, and I'm going to substitute back in the variable that I chose. 3x plus 7 equals 2x plus 18. Okay, so there's that. Again, you are using different numbers. This is why I hesitated to put this one on a video, because I know that sometimes you just watch these and then write in what I have. I don't want you writing this in. You're following this process. So the last part of it says we have to solve our equation. Okay, so I'm going to go ahead and solve it. And I think what I'm going to do is subtract 2x. I mean, you have lots of choices. A lot of you seem to like to say, ooh, I'll subtract 7 there. That's fine too, okay? X plus 7 equals 18. Now I'm going to subtract 7. So x equals 8 minus 7, 11. And that's what I wanted to prove, right? So my equation that goes on the line is this. For me, that's Mrs. Golding's equation because I chose the letter X. I chose the number 11. I chose to multiply it by 3 and add 7 and multiply it by 2 and add 18. That is my choice. That's different than what you're going to get. So I'm actually, since if somebody is just watching this, I want to somehow, what could I do here? Erase it all. Oh, my heavens, it got big. Okay, pretend I'm erasing this whole thing. Can't. Okay, I'm going to exit out. So if you're watching this, highlighter, exit out, and I'm going to write, do your own. So don't use mine. Don't use mine. So those of you that just watch it but don't turn the volume on, okay, there you go. All right, so I'm going to come down here now. And the last thing that was requested of me was 12 through 14. This is Randy the runner. And Randy has this goal to run a total of 25 miles. Okay, so he's already run more than half of that. And then he has to run this far, and he wants to run 2 miles each day. So how far is that? 13 to 25. What's 25 minus 13? 5 minus 3 is 2. 12, right? So he has to go a total of 12 miles. These are all miles. Okay. And so then I know after 2 days, after 1 day, he will have run 2 more miles. So he's at 15, 17, 19, 21, 23, 25. So how many days was that? 1, 2, 3, 4, 5, 6. Now, the question says, and I'm looking for a question mark. Write an equation to determine. There's really no question mark, but we see this word determine. So that's what we want to find out. The number of days it will take him to meet his goal. What did we just say? 6, right? Now, we just solved this problem, but we didn't do what the question was asking us to do yet. Remember, a solution is just part of what we're looking for. It's the process that's most important. And I demonstrated using a visual model to help me understand what's going on. That, if you are a visual person, this is a good place to start because then you can kind of decode what's happening here. So the first thing it says is define a variable. Well, I'm looking for the number of days, so I might use D. Let D represent the number of miles Randy must run. Okay, good. Now, an equation, as we said before, has an equal sign. It has a variable. D, right? I could put it on the left side or the right side. Doesn't make any difference. So what I like to do is I know in an equation, the expression or value on the left must be equivalent to the value on the right. So with these kinds of questions, I like to look for the big picture here. What did I start with? Well, I know Randy's goal, right, is 25 miles. And then the other stuff that he's doing is going to have to equal that 25 because that's the big goal. Well, he has already run 13 miles, right? He's already done that. But added to that 13, he's going to have to go some amount of days and he's going to run 2 miles per day. Okay. So I have to figure out how many days that is. I just wrote an equation and I used the picture that I have right here because I can visualize the whole. I can talk about the starting point, and then I can talk about what else needs to make that up to get to the whole. I actually just wrote a linear equation with a slope of 2 and a y-intercept of 13. Amazing. Now, I get to write the equation. That's number 13. Then I'm going to solve it. Well, let's subtract 13 from both sides, which is actually what we did right here to get that. Remember when I was thinking about what's 13 plus what is 25? That's where that 12 comes in. And then here's where, instead of adding repetitive addition of the number 2, right? Isn't that the same as multiplying by 2? Yes. And multiplication and division are opposites. So I'm going to divide by 2. So 12 divided by 2 is 6. 6 more days to meet his goal, right? So I now defined my variable and I wrote my equation. Okay. So these were the problems that were requested of me. So hopefully that's helpful to you. I hope you have a fabulous day. Remember, you are important and the world needs you. I do too.